Hello guys, welcome back to my YouTube channel. I am Maunika, currently pursuing computer science and engineering from Sri Venkateshwara College. Course title Digital Design and Computer Organization. Today I will discuss about a review of logic gates and its applications. Abstract. In this paper we have discussed different types of logic gates and or not NAND, NOR, XOR, XNOR and corresponding logic tables. The base of any digital computer system are logical gates or circuits which perform logical operations on chunks of information represented digitally. Logic gates work on basis of binary digits 0 and 1. Any intelligent system with the abilities to take decision compromises of simple logic gates. This paper is an attempt to bring forth the application of digital logical gates in a day-to-day life with some real-time application as well as like burglar alarm and security system. Through the study of number of physical system, example mechanical, optical, electrical, thermal, biological system, it can be said that modeling of any such a system can be done logically with the help of Boolean expression. Accordingly, such a system can be studied mathematically. This paper is a generic effort in understanding the Boolean mathematics behind the physical system around. The word logic itself gives us an idea that they work on certain kind of logical operations. Logic gates are integral parts of digital mathematics. A logic gate is a device performing an elementary Boolean function producing a logic 0 or 1 output depending on one or several such logical inputs implemented with either electronic, optic, mechanic, or even biological devices. Logic gates can be composed into physical models of all conceivable algorithms or computations. Generally, for every logic gate, we have only one output, but in case of input, it may vary. But for logic gates called not have only single input and single output. Logic gates are building blocks of digital circuits in which diodes and transistors are used to perform switching functions. By combining thousands or millions of logic gates, it is possible to perform highly complex operations. A truth table helps us to show the function of a logic gate. It shows the output states for every possible combination of input states. Types of gates. AND gate. An AND gate receives A and B, where A and B are bits and produce output denoted by A dot B, where A dot B 1 if A is equals to 1 or B is equals to 1, 0 otherwise. An AND gate is as shown in below. OR gate. The OR gate receives input A and B, where A and B are bits and produce output denoted by A plus B, where A plus B is equals to 1 if A is equals to 1 or B is equals to 1, 0 otherwise. An OR gate is as shown below. NOT gate. A NOT gate or inverter receives input A, where A is a bit and produces output denoted by A, where A is equals to 1 if A is equals to 0, 0 if A is equals to 1. The NOT gate is shown below. NOT and AND gate is equal to an AND gate followed by NOT gate. The output of all NAND gates are high if any of the inputs are low. The symbol is an AND gate with a small circle on the output. The small circle represents inversion. The NAND gate is shown below. If input A is 0, input B is 0, x is equals to 0 into 0 is 0 and 0 the whole complement is 1. NOR gate. NOT and OR gate is equal to an OR gate followed by a NOT gate. The outputs of all NOR gates are low if any of the inputs are high. The symbol is an OR gate with a small circle on the output. The small circle represents inversion. The NOR gate is shown below. Input A is 0, input B is 0, x is equals to 0 plus 0 is 0 and 0 the whole complement is 1. Exclusive OR gate. The exclusive OR gate is a circuit which will give a high output if either but not both of its two inputs are high. An encircled plus sign is used to show the exclusive OR operation. The exclusive OR operation gate has shown below. If both the inputs are 0, the output is 0. If both the input is 1, the output is 0. If one input is 0 and one more input is 1, the output is 1. Exclusive NOR gate. The exclusive NOR gate circuit does the opposite to exclusive OR gate. It will give a low output if either but not both of its two inputs are high. The symbol is an exclusive OR gate with a small circle on the output. The small circle represents inversion. The exclusive NOR gate as shown below. If both the inputs are identical, it gives the output 1. Applications. The applications of logic gates are mainly determined based upon their truth table, that is, their mode of operations. The basic logic gates are used in many circuits like push button lock, light activated burglar alarm, safety thermostat, and automatic watering system, etc. Digital communication cannot happen without logic operations. Daily life applications of EOR and ENOR gate can be related to ladder switches used in home or can be found in water level checker circuits. AND gate. AND gate are used to combine multiple signals. If all the signals are true, then the output will also be true. If any one of the signal are false, then the output will be false. ANDs aren't used as much as NAND gates. NAND gates use less circuits and have the advantage that they used as an inverter. AND gate is used in the security alarm, for example, as shown below. OR gate. Whenever the occurrence of any one or more than one event is needed to be detected or some action are to be taken after their occurrence, in all those cases OR gates can be used, for example, as shown below. NOT gate. NOT gates are also known as inverter because they invert the output given to them and show the reverse result. Now the CMOS inverters are commonly used to build square wave oscillators which are used for generating clock signals. The advantage of using this is they consume low power and their interfacing is very easy compared to other logic gates. For example, as shown below. Applications of NAND gate. First, device failure alarm system. When the OR fans are working, the input to the NAND gate is 1 and the output is 0. If any one of the fans stops working, the output of the NAND gate becomes 1, which activates the alarm. Second, burglar alarm. When the switch is closed, one of the input of the NAND gate is low. When the LDR is in the light, the other input is low. This means that if either of these things happen, that is switch is closed or the light is on, one of the input is low, the output is high and the buzzer sounds. Third, freezer warmer buzzer. When the thermistor is cold, its resistance is lost and the input to the NAND gate is high. Since the NAND gate is connected as an inverter, the output is low. As the thermistor warms up, its resistance decreases. The voltage across it falls and the input to the NAND gate falls. When it becomes low enough, the output becomes high and the buzzer sounds. Application of NOR gate. Washing machine controller. A washing machine has three sensors to check for washing machine lid open, washing tub filled to minimum level, and weight of clothes and water in tub. If the machine lid is open or water in the tub is below the certain level or machine is overloaded, the output of the corresponding sensor is set to 1, producing a 0 at the NOR gate output that switches the machine off. I finally conclude that logic gates are fundamental building blocks of digital electronics and computing system. They are responsible for processing binary inputs to produce desired output based on Boolean algebra. The basic gates include AND, OR, NOT, NAND, NOR, XOR, and XNOR, each performing unique logical function. By combining these gates, complex circuits can be created, enabling the design of digital systems such as computers, smartphones, and more. Logic gates are essential components in digital electronics, enabling basic binary operations that form the foundation of more complex circuits and systems like computers, calculators, and processors. They are vital for performing computations, decision making, and data processing in modern technology. Thank you. Like, share, and subscribe my video.